you? Oh, you had the Easter also.
Yeah.
Okay. All right. So for 7.2, we're going to talk about trigonometric integrals. Okay. I'm going to give you some trick to do this. So and at the end, we're going to play a game. Kind of like the Easter egg hunt, but so we don't have the Easter egg hunt, but I'll prepare a game for you guys to play with. First of all, so remember this trig identity, right? Sine square x plus cosine square x equal to 1. Okay. So to do trigonometric integral, let's first remember this identity. Sine square x plus cosine square x equal to 1. And keep this in mind. That's going to help us to do trig integral. Okay. Now let's start with this integral. Notice that the exponent on cosine x over here is odd. Okay. So how do we do this type of integral? Now for this type of integral, remember this identity. When you have sine x times cosine x, and when the exponent on either sine or cosine is odd, okay, think about this identity. Now over here, the exponent for cosine here is odd. I want to use this identity later. I want to make this exponent here to be even, okay? So what do we do? So we need to save, okay? So I'm gonna break this into two parts. One part here is cosine square x, and the other part over here will be cosine x. So over here, I save one factor of cosine x over here together with the dx. So then the remaining part here, you have an even power for this cosine x. So I can use this identity later, okay? Now, when I have done this, when I have separated this into this times this, what happened here is this part over here, what does it become?
Sine of x? No.
No,
You
d cosine x, d sine x.
d sine x, okay? So notice that, yeah, I told you guys to with the 7.2 before class. So then when you come here, you have some idea, okay? So, but I'm gonna go over this, okay? So when you differentiate sine x over here, with respect to x, we get cosine x, right? Okay. So d of sine x here will be cosine x dx. So this differential d sine x here is equal to cosine x dx, okay? So when I save this cosine x together with the dx, and that will become d of sine x over here. So that's d of sine x. Now that will become an integral with respect to sine x. Now this part over here, I want to express this in terms of sine x because that's an integral with respect to sine x. So we use this identity, express cosine square in terms of sine. So that will be what? 1 minus. So that will be 1 minus sine square x. So when we express this cosine square x in terms of this sine x over here, we use that identity, and that become 1 minus sine square x. Now after this, we can use the u sub, okay? So we can think about this sine x as a u.
Teacher, we can't use integration by parts here because it's multiplication.
This one here, you can, this one here, you can, not integration by part, okay? Is something called, there's a pattern. So I'm gonna tell you the pattern later. It's not integration by part, yeah. So,
okay, thank you.
Yeah, okay, good question though, okay. So after that, we can regard the sine x here as u, okay? So this is du, and this become 1 minus u squared. So this is a simple integral, right? Okay, we know how to find antiderivative this. What's the antiderivative this?
U minus u to the third power over 3.
Good job. And don't forget to what?
Plus c.
Plus c, okay? Now this is u, right? However, we want to return back to x.
Substitute back.
Yes.
Sine x.
And now we have complete the problem over here. So if you want to see if this is right or not, you can differentiate this. You should come back with this function that you integrate with, cosine cube, right? You can try to differentiate, see if you get back cosine cube of x. Now there's a pattern I can tell you over here, okay? So there's a strategy. The strategy is actually down over here. I wrote down right here. For this type of integral, when the integral here is sine x cosine x, with the exponent on sine or cosine here being integers, and when the exponent on cosine here is odd, what do we do over here is, okay, when it's odd, you can think about this as like 2n plus 1. And what do we do over here? We're going to save one cosine x together with dx. So then the remaining exponent on cosine will be even, okay? So basically, you want to remember this trig identity. Sine squared plus cosine squared equal 1. Okay, so remember this. So you try to make the exponent on cosine here to be even, so then you can use this identity. To make the exponent on cosine here to be even, you want to save one cosine x together with dx. That way, the remaining power on cosine x here will be even, okay? And after that, this part will become d of what?
D sine x.
Sine x.
Sine x, okay? Now, after that, this is an integral with respect to sine x. You want to express all of this in terms of sine x. This part here is already in terms of sine x. You don't want to change it, so you keep this part. And for this part over here, this exponent on cosine x here is even. So then you can use this identity to express this in terms of sine x. And then the last part over here is do the use up. So you're going to let this to be u. So this last part here is you let this u to be sine x. And then this will be in terms of u, and then this is du. Okay, and then you know how to do. Okay, so this is when the exponent, when you have this type of integral, sine x times cosine x, when the exponent on cosine x here is odd, you're going to save one cosine x together with dx, and then the remaining power for cosine x here will be even, and then you can proceed like this. So that's the first step. Save one cosine x with dx. Do you guys have question about this?
No.
Okay. All right. Now let's do another one. Now this one here is also, the integral here is also sine x times cosine x. However, this time the exponent for cosine here is not odd. Okay, it is even here. However, the exponent for sine here is odd. So any idea how do we do this?
Sine to the sine 4x times sine x. Exactly.
Yes.
Yep.
You got it. You want to save one sine x to get together with dx. So it's going to become even, the exponent on sine. So after you save one sine x together with dx, the exponent on sine x here will become even. now to the 4 power. This one here, you don't want to change. Okay, so you just copy. What happened to this sine x dx?
Negative d cosine x.
It's negative d cosine x. Okay, now let me give you some explanation. When you differentiate cosine x with respect to x, you get negative sine x. Therefore, sine x dx, it is negative d cosine x over here. So we can replace this sine x dx over here by negative d cosine x. Now this part over here is already in terms. Now later the integral will be in terms of cosine x because this is d cosine x. So this cosine x, cosine square x here, you're not going to change. You're going to just carry that, okay? So this part over here, you just carry. What about this part over here? What should I do?
1 minus cosine square x square.
Yes. So remember we use that trig identity, sine square plus cosine square equal 1. Now this one here is not sine square x. It is sine to the 4 power. Okay. So this is the square of sine square. So we can express the sine square here by 1 minus cosine square. And then later on, square again outside. You see what happened over here? The 4 power here is the square of sine square. Sine square is expressed as 1 minus cosine square. So you're going to square this 1 minus cosine square. That will be sine to the 4 power. Now this part over here, you just carry that down. Now this part here is negative d cosine x. Let's put the negative sign in front of the integral. So I have this negative sign in front. So it's negative d cosine x over here. Now, by doing this, you see all of this. This is an integral with respect to this cosine x. And all of these are expressed in terms of cosine x. Then we can use the u sub, okay? So we're gonna let u to be this cosine x, and all this become u, okay?
Did you come up with this, professor, or did somebody else?
This is the second time you ask this question.
Oh, okay, okay. No, I'm just curious. Yeah.
I come up with this diagram, but the idea is I didn't discover the idea, but I come up with say, oh, let's remember this pattern. So in the past, they just say, okay, if you have this type, you save this. If you have this type, save this. But I say, how can my student remember this, right? It seems like a lot to remember. So I'm thinking about, I come up with the, you look at the
Diagrams.
identity.
Yeah, that's
Yeah,
helpful.
the
Thank you.
identity. Yeah, I come up with that. Okay.
Teacher, so we set always u to be the identity inside the d.
Yeah, you always let the last step is always let u to be this inside the d, this, okay, and then everything over here had to be in terms of this, okay.
Okay, I see. Thank you.
Okay, so the last step you let u to be this cosine x. So all this cosine x you express them in terms of u, okay. So what will be the next step? The next step is to, now this integral over, for this integrand over here, you would just want to multiply this out term by term. So you can integrate the term by term to find untitled t, right? Okay. So this is a polynomial in U. So to multiply this out, square this, use the perfect square formula. Okay, tell me what you get. 1 minus
2u squared
2u squared plus u to
plus
the
4u
4.
to the
You
4th
got
power.
it? Yes, you got it. And you multiply this, okay, distribute the u square in, okay. You guys got it? So after you expand this perfect square here, use the perfect square formula, you distribute this u square inside, and you come up with this polynomial in u. Okay. Now you can find antiderivative term by term, right? So what would that be? U to the
Third over 3 minus 2u5 over 5 plus u7 over 7 du
don't forget plus.
plus c.
Yes,
Yeah.
you got it. Okay. Now finally, we want to return back to x. And at the same time, I'm going to distribute the minus sign in it. Okay. So the u here, it is what? Cosine
Negative
x,
cos x 3 over 3
right?
minus 2u. Oh no,
Plus
2 cos
2.
cos 5 over 5 and then minus cos 7x over 7 plus c.
Got it. Yes. Okay, good job. Now you get a hand of it, right? So instead of trying to remember that without any pattern, so I gave out the pattern. So you see, okay, let's summarize this one, okay? So when you have this integral here is sine x times cosine x, when the exponent for sine x over here is odd, what's the first step?
Wait, repeat?
When you have this, when the function that you integrate with is in the form of sine x times cosine x, with the exponent for sine x here being odd,
Split them up.
you split them up, right? You want to save, okay? So again, you think about that trig identity. So think about this. Later on, we need to use this trig identity. So to use this trig identity, the exponent on sine or cosine has to be even. So we wanted to turn that to be even. So you split it up or you save one sine x together with dx. Now the remaining part here, the exponent on sine will be even. Then later you can use this trig identity. Now, after you save the sine x with dx, what does this turn into?
Negative d cosine x.
Negative d cosine x. You got it. Okay. Now, this integral here now is going to be in terms of cosine x. So this cosine x over here, okay, cosine to some power, some power of cosine x. This part over here, you're not going to change, because that's already in terms of cosine x. So you just keep it. And then this one over here, you want to be in terms of cosine x. Then we use this identity. Then this integral will be all in terms of cosine x. And then what's the final step? What's the last step?
Use up.
Use up. And then you're going to let this cosine x here to be u. And then later on, you can return back to x afterward. You got the idea? So always remember this identity. You want to turn the exponent for sine or cosine to be even. So you're going to save one sine x over here together with dx. So that will change to even power. Okay, you got it? Okay, all right.
Teacher, if both the exponents of sine and cosine are even, we use another method, right? We can't use this method.
Yes. So that's a good question. So I'm going to get to that in the next maybe the next example. Okay.
Oh, okay.
I'm salting on
Thank
it
you.
though. Holy moly.
Okay. All right. Now some people will ask, what happens when the exponent for on sine x and cosine x are both odd? Then you can use either strategy A or strategy B. Okay. You can save either the sine x together with dx, or you can save one cosine x together with the dx. Either one will work. The answers will be equivalent to each other. Okay, so you can use either one. So every time you see the exponent on sine or cosine to be odd, then you think about save one of them, right? Okay. Now, Sultan's question was this, right? So what happens when the exponent on sine and cosine are both even? To deal with this type of integral, then we use the half angle formulas. The half, this two are the half angle formula. I don't know if you guys remember. Do you guys remember that? Now maybe, right? Okay. So that's a half angle formula. Okay, you probably remember double angle formula. This one here, you can get it from that. Okay, so these two are the half angle formulas. So when you have sine square x, you can express into this. Cosine square x, you can express into this. Okay, now let's do this one as an example. So we use a half angle formula here, and this part over here is going to become, so this is going to become this. Now we can find antiderivative. But first of all, let's take out this 1/2 here, this constant multiple. So we take out this constant multiple 1/2 in front. Now let's find antiderivative here, turn by turn. So what's antiderivative of 1?
X.
Pi.
X, yes. Minus, okay, antiderivative of cosine 2x.
1 over 2 cosine 2x.
Yes, sine of 2x over 2. So when you differentiate sine of 2x, you get 2 times cosine 2x. So, and then you divide by 2, you get cosine 2x. So x here go from 0 to pi. Now we're going to substitute the upper and lower limit. Okay, substitute pi in it. Now substitute 0 in it. What's sine of 2 pi?
0.
Sine of 0?
0.
0. So the result here will be equal to
Half a pi.
pi over 2. Okay, that's pi over 2. Okay, now we can try to visualize this result. This integral over here represents this area under the curve of sine square x. So this is the curve for sine square x. From 0 to 2 pi, it is yellow highlighted area. That's equal to pi over 2. Okay, sine x is like this. Sine square x is like this. Okay, so this is equal to pi over 2. Okay, question? Okay, now before I move on, let's play a game. Okay, so I'm going to stop share right here. Okay, let's play an Easter game. Okay, so whoever can answer this the first will get a prize. Okay, are you guys ready? Okay, this. Okay,
Your
this.
body.
Yeah.
You can see it, right? So when the function that you integrate with,
There we go.
Right there. Put it in front of your body.
yes, when the function that you integrate with in the form of sine x times cosine x, with the exponent on sine x over here being r. So what's the first step?
You save
If
one of
you
them,
want
right?
to
The odd
save-
one.
One of them, which one?
Sine.
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 Sine
Sine.
of
Sine.
x.
You save one sine x together with dx, right?
Yeah.
Yep.
You got it.
Mhm.
So you save one sine x together with dx.
Who won the prize?
Who
All
on
of
the prize? Okay, I'm going to look at the recording and then see. Determine who's
Okay.
the winner. It's all recorded. Okay, good job. Okay. All
Good job,
right.
everybody.
Okay.
Nice.
Okay, ready for the next one. Okay.
We
Save one
say
cosine.
Save
cos
one
sine of
save it
x.
from the cosine.
Turn some sine x.
What did you guys say? Say it one more time.
We all said the right
Save
answer.
1 cosine x
Yep.
with dx.
One cosine x together with dx, right? Okay, you got it. Okay, good job. Okay, so you save one cosine x together with dx, and what does this cosine x dx become?
Mm.
D
d
sine
sine
x.
x.
Okay, you got it. Good job. Yeah, it become d sine x. Okay, good, nice. Okay, the next one.
Half angle formula.
Half
We
angle
use
formula.
half angle formulas.
The answer here is to use a half angle formula. Okay.
Mhm.
You can all win some Easter egg. You can get 1 egg from here, from my background. So it's 12:04. You guys okay? Or should we continue with this? I think I would just stop here.